Dear world, welcome back to the greedy algorithm session. So in today's session, we'll be studying everything about greedy algorithms, all the algorithms, concepts and examples. So this is an introductory session and introductory video where we'll be understanding the basic concept of greedy algorithm. So in first, we'll be learning the introduction of greedy algorithm. Second, then the important terms in greedy algorithm. In greedy algorithms, we'll always find few important terms that we need to know. Then the greedy strategies. Greedy algorithms are three strategies that are greedy choice property, optimal solution, non-greedy problems. We'll be understanding those. Then the major three greedy concept, and then we'll be learning that how we can solve problems step by step using the greedy algorithm. Then the example 6 activity selection problem and fractional knapsack problem that we'll be studying in next class, not in today's session but in next session. And then the greedy application. So what is greedy algorithm? It is the algorithm where the optimal decision comes after because of all the step by step decisions. Let's understand from this. Suppose there is a stairs and our main goal is to reach in the top. Our main goal is to reach in this top where we will be hosting our flag. Our main goal is to reach there. So what we do in each step, that we can take two decision. Look, suppose a man is here, and now from here this man can take either two decision. First decision of moving upward, let's say we are representing it by 1, and its second decision can be moving downward, let's say we are representing it by 0. So there can be two major decisions, either moving upward or downward. So in every step you have to take a decision of moving upward or downward. In greedy algorithm we always try to maximize the thing. So here we take a decision that he will move upward, that is 1. Then again in this step we again take a decision to move upward 1. Then again in this step we take a decision 1. Then again in this step we take a decision 1. Then and the final we reach here. So now observe, we took decision in every step, one by one. So there is step by step decision taking. Decision taking is done by step by step. Step by step decision is taken. So this is where we take the decision step by step at every local maxima without considering about the future. That means we will not consider about the future. That is greedy algorithm. We do not consider about the future. This is greedy algorithm. So this step by step decision taken is called greedy algorithm. That is greedy algorithm that we'll be studying. So first let's start the introductory session. I give you a brief idea right now. So greedy algorithms. Greedy algorithms are a paradigm for solving optimization problem by making a series of choices. Look, here it is told that by making a series of choices. That means we make a series of choices or series of decisions as an objective, that either in case of stairs we can take a decision to move upward or move backward. So we took a decision one by one, series of decisions we took. We took decision in here, in here, in here. So in all the steps we took the decision. So that is by making a series of choices that seem best at each step. So that was the best choice for us in that step. That seems best at each step. The hope is that local optimization will lead to global optimal solution. So what was our main hope? That our local, look, now every time we took those decisions, that either he will move on. So these are the decision at local. These are called local decisions. And our hope was that our local decisions, those all local decisions will reach us to the main this place, the optimal decision. So this was our main goal and main hope, and this is why we utilized the greedy algorithm. So will lead to a global optimal solution. In this chapter we'll discuss the core concept. So as I told you, we'll be discussing the core concept, and the core section will be discussing in Java. Now again let's take another example to understand the greedy algorithm much better. Suppose there is a people A. Suppose there is a man who is A, and this people wants to travel from New York. He wants to travel from New York to California. Let's say he wants to travel to California. So the people wants to travel from New York to California. So this is the travel way. So how he can travel from New York to California? There can be multiple strategies. That first he can go through by his walking. He can go. There can be a strategy to move here. Is he can go strategy one, that he can think to go by walking. By walking he will move. Second strategy can be he can go through cycling. The second strategy can be that he can go through cycling. The second strategy. Third strategy can be that he can take any public transport or bus. He can take any public transport or bus. So that is third strategy. There can be fourth strategy. That is fourth. There can be fourth strategy, that he can either go by train. He can either go by train. So let's call it train. He can either go by train. And there can be multiple more. There can be also one more strategy, that he can either go by plane. He can either go by plane to New York. So these are the strategies. These are all the tracks or the ways how we can go from New York to California. Now let's try. We're giving one more condition here, that the man must reach within 10 hours. The man must have to reach from New York to California within 10 hours. So what are the strategies or ways through which he can travel from New York to California? There is only two ways. Either he have to take train for faster journey, or he have to take plane. So the step 5, that is train. Either he have to travel through train, or he have to travel through plane. So these are only strategies that he is having. Now look, we got only two steps that can work for him, and these are called this solution is step 5, and this solution is step 6. These are called the local optimal solutions. These are called actually feasible solutions. These are called the feasible solutions. Why? Because look, let's say it can travel in 6 hours. The train can travel in 6 hours, and the plane can travel in 3 hours, and the criteria was that we must have to reach within 10 hours. So our strategy 5 followed in 6 hours, and strategy 6 followed in 3 hours. So they only followed the condition or constraint that was given. So whichever follows the condition or constraint given, that is called feasible solution. So this is called feasible solution. Now look, either among this one and this one, suppose we applied another condition, that was condition 1. Now we applied another condition. Condition 2 is the cost should be minimum. Cost should be minimum. Cost should be minimum. Cost should be minimum. So in that case, what we have to do, we have to find what will be the minimum cost. Let's say the cost for train was $20. The cost was $20, and let's say for the plane it was $200. So that was the cost. So what is the minimum cost? That $20 is the minimum cost. So only out of so many solution strategy 1, 2, 3, 4, 5, 6, only one gave us the minimum solution that followed both the conditions. Conditions 1, condition 2. So this is $20. We call this one the optimal solution. This one the optimal solution. We call that one optimal solution. And notice, there will be always only one optimal solution. There will be always only one optimal solution. So there's only one optimal solution. So that is what gave us the optimal solution. Now we'll be understanding few important terms that we'll be utilizing in all the greedy algorithms. So let's move to the next page. Greedy algorithm important terms. First we'll be studying greedy choice property, that we'll be getting in most of the cases. Greedy choice property. So what is greedy choice property? Did you notice in case of each steps, we took the decision. We took decision either to move forward, either to move backward. What was 1 or 0? So among those we took one decision, either 1 or 0. This is called the greedy choice property. So let's study. Making a locally optical choice at each step leads to a global optimal solution. Look, so this is that we took always a decision at every step. At this step we took decision, at this step this took decision. That is in terms of programming language, algorithm language, is called greedy choice property. So these decisions are called the greedy choice property. Greedy choice property. Greedy choice property. Optimal subtraction. Now observe, what is optimal subtraction? Now in our case problem, what we noticed, that those decision here one, here one, here one, here one, could lead us to the final decision where we would host our flag. So this was that our sub-problems or suboptimal solutions could lead us to main optical solution, that is called the optical substructure. This entire system we can call it the optimal substructure. So let's study. A problem exhibits this if an optimal solution can be constructed from optimal solution of its subproblem. Optimal solutions of its subproblems. So if this is the main entire is the main problem, we can call this, we can call all those subproblems. So this entire structure we can call it as optimal substructure. Optimal substructure. Locally optimal. So in every step we took some decision. Here we took the decision 1 to move forward. This is called locally optimal because that was the only base decision we could took at that position to reach our goal. So this is locally optimal. Globally optimal. Now globally optimal is that here we can understand reaching this peak is global optimal. Suppose if we take another example, there is a hill. This is also example of greedy algorithms that I'm telling you. This is called greedy hill algorithms that you will be getting in artificial intelligence. So suppose then there is a lot of these are. So you are people whose eyes are closed. That means you cannot see. You have make you blind using cloths. So if you are from here and if you just move one step forward, what you will be feeling that you will go downwards. Then you will be thinking that this is the maximum peak for you. So for in your case it becomes the locally optimal. You will think that that is the global optimal, but not. That is called local optimal. This is local optimal or the local highest. This is another localized, this is another localized, this is another localized. But if our goal is to reach the main point, that is this section is our goal, then this is above everyone, and that we can call it globally optimal. That means the main approach, this is globally optimal. Okay, now feasible solution, a solution that satisfies the problem constraint. Problem constraint, that means problems condition. If the conditions are given and if that satisfies, we call it feasible solution. In our case, the only one solution followed both the conditions, this condition and this condition. So it was optimal solution and feasible also. And first feasibility that follow the condition, that is feasible solution. So if it follows the condition, that is called feasible solution. Now coming to the another candidate set. Now look, if you observe this program, so we got everywhere some values from each set at each strategy. We got 1 1 1 1, and after getting a 1 at each step we reached up to the main point global optimal. So this set is called candidate set. A set of potential choices for each step in greedy algorithm. This is called candidate set. Selection function now determines the best candidate from the available options at each step. Look, if there is a step 1 1 1 0, or there is multiple choices that 1 0 0 1. So if we have function that determines the best one, we call that function the selection function. That function is called the selection function. Objective function measures the quality of the solution to optimize, example, minimize or maximize cost. Now look, objective function, our main goal in greedy algorithm becomes what? To either minimize or maximize. What you do in greedy algorithm? Greedy algorithm. Look, greedy algorithm we get an important term, that is optimization. Optimal solution. And this optimal solution does what? Do you know? This optimal solution either minimizes or maximizes. So it will either minimize, or it will maximize, maximize. So either it will minimize or maximize. That is the main objective function of optimization problems. That is the main function of optimization problems. And those optimization problems we can solve by three strategy. First, by three strategy or by three techniques. First, that we are right now studying, that is greedy algorithm. Second way how we can solve the optimization problem, that is using dynamic programming. What is very important in terms of our programming and placement? Dynamic programming. And the third way how we can solve those optimization problem is branch and bound. Is branch and bound. So these are the way how we can solve the optimization problem. So that is objective function we got to minimize cost or to maximize cost. That is the main function of objective function. Now matroid, a combination of a structure that generalizes the greedy methods. So what generalizes all the greedy methods? Applicability, that is called matroid. Knapsack problem. So we get a knapsack problem. Knapsack problem is of either two types. Either we have to take 0-1 knapsack and fractional knapsack. So we'll be studying that in the next sessions. So that is a knapsack problem. Another important things in greedy algorithm introductions. Now we'll be studying greedy algorithm strategy. Let's understand how greedy algorithm works. Greedy algorithm works in stages. As I've already made you understand that the greedy algorithm works in stages. In each stage, a decision is made that is good at that point. That means in each stage we took the best decision that is good at that point without bothering about the future. That is, in here we don't bother about the future. That means some local best is always chosen. So whatever the decision we took, that is best, but local based in that position, that is best. It assumes that a local good selection makes for a global optimal solution. That means in greedy algorithm we assume that whatever the local decision one by one, step by step we take, all the local decisions will reach us to the optimal solution. We assume this in greedy algorithm. Now greedy algorithm concept. Greedy choice property. The solution can be constructed by choosing the best options at each step. So these are same as I told you that we always choose the best option at each step. We always choose the best option at each step without needing to revisit the previous decision, and we don't consider about previous decisions. If suppose reaching from New York from reaching from New York to California, the example that was our person here. So whenever we take decision to move here, we don't consider. Suppose we are a journey by plane, so we don't consider about other strategies that were available. We don't consider previous or after. That is greedy approach. Optimal substructure. As I told you that we always calculate the optimal, that if we can reach in the optimality or not. That is another. The problem can be broken down into smaller problems, and the solution to the problem can be derived, and we can derive the solution from those sub problems. That is, in greedy algorithm we always break a larger problem into smaller problems, as we did in step by steps. We took decision at every step, and that reached are the final strategy. Non-greedy problems, another important things in algorithm, that there are various algorithm what cannot be resolved by greedy approaches, like problems that need to make global decision based on future consequences. Suppose if some problems requires the requirement to take decision in future, we cannot solve those based on greedy algorithms. Now greedy algorithm steps in solving problem using identify. So these are the same things that I told you. Ensure that the problem has an optimal substructure. So before, how we can identify or understand that if we should apply greedy algorithms or not. So from here we should be ensured that that has an optimal substructure. First we should see if that is having an optimal substructure. If the problem is having an optimal substructure, which means the optimal solution to a problem can be constructed efficiently from the optimal solutions of sub problems, as I told you. Second, greedy choice property. Prove that making the greedy choices at every step leads to an optimal solution. That means the decision we are taking, we should know that those decisions must lead us to optimal solutions. So that is greedy choice property and greedy choice design. So these are applications where we apply greedy algorithms. These are the few major applications where we apply greedy algorithm. So activity selection problem. Select the maximum number of non-overlapping activities. So in case of activity, if we want to find the max number of overlapping activities, then we use this greedy algorithm. Second, in Huffman coding, we also use this greedy algorithm in Huffman coding. Optimal data compression using a binary tree for variable encoding. In Huffman coding, we use this for optimal data compression. What this means, optimal data compression? That means suppose we want to compress the data at the highest level. At highest level, that means we want to make the size as minimum as low. That means for minimizing the size, we use this greedy algorithm in Huffman coding. Now Prim's and Kruskal MST algorithm. In Prim's and Kruskal, we use this to find the minimum spanning tree. Also we use here to find the minimum spanning tree. Minimum spanning tree, we use greedy algorithm in Prim's and Kruskal's. We also use this in Dijicestra's algorithm, shortest path from a source to all the other vertices in a weighted graph. To find the shortest path, we use this greedy algorithm in Dijicestra's algorithm also. Fractional knapsack problem. As I told you that fractional knapsack problem is of two types, that is zero on fractional knapsack and another is fractional knapsack. So we use here also the greedy algorithms. Now these are for using job scheduling deadlines. This is also important problem in corporate world. We try to maximize the productivity. So here every job is provide. We try to maximization of profit. Maximization of profit. So for maximization of profit in companies, we use the greedy approach. Now optimal merge pattern for minimizing the cost of merging files. If you want to minimize the, while merging the files, you want to minimize the cost, minimize the time, optimize the least time. For that we use greedy algorithm. For graph coloring, suppose for there is a graph and we want to color the graph. So how many colors should we use? We try to find the minimum number of colors, and for those cases we also use the greedy algorithm to find the minimum number of graph coloring. We use the greedy algorithm. There also we utilize the greedy algorithm. Now these are the applications, and we knew quite a lots of things about the greedy algorithm. So these are all. So in next session we'll be observing the coding session. That was theoretical conceptual concern where we understood the greedy algorithm. In next session we'll be understanding a lot of examples, activity selection problem. Then we'll be observing the fractional knapsack problem that we did, and mainly we'll be observing the coding session. So till now, thank you. That's all. We'll be meeting in the next video.